Hello everyone, am I audible and visible? Fine. Am I audible and visible? Let me know. Okay, fine. Yes, I'm audible. So, hello everyone, welcome to my class. I'm myself Dr. Deepthi Karya. I'm MD PhD Physiology. Hello Ashish. I'm MD PhD Physiology and I'm your educator for Physiology. Okay. So, in this channel, uh, okay, fine. In this channel, I'm going to upload videos of physiology and I'm trying to complete the whole syllabus of physiology. Okay, so if you're regularly watching my videos, you can complete your whole physiology syllabus. Fine. Another important thing, all the notes of my lectures that is available in soft copy uh, as well as hard copy. Ashish, yes, I will try to start blood. Okay, let's see. Let me finish this general physiology, then we'll start the next topic. Fine. You can suggest if you have query in particular topic, then we can start that also. Fine. Huh. So my all topic notes they are available in soft copy in my app Vesalius. You can download the app. Download is free, and you can get the subscription. Also, hard copy is available. Physiology notes you can order from Flipkart as well as Amazon. Okay, now let us start today's topic, that is action potential. Fine. So yesterday we started the discussion about action potential. We have discussed about the ionic basis of action potential. We have discussed about various phases of action potential. Fine. So now today we'll discuss about something about biphasic and monophasic action potential. That is one thing. Second, we will discuss about compound action potential, and at the end we will discuss MCQs. Fine. So let us start with recording of action potential. This recording of action potential is of two types. Okay, one that is biphasic action potential. This is biphasic. You can see here two phases are there in the action potential. What we are recording, that is monophasic. So this is your biphasic action potential. Now, how to record biphasic? We have discussed yesterday monophasic recording. One electrode is placed inside the tissue and other electrode is outside. But here in biphasic, you can see both the electrodes are placed, you can see here, outside the membrane. Okay, both the electrodes are placed extracellularly. Okay, here you can see very important thing, when both the electrodes are placed outside the cell in resting state, you will not get any potential. You can see here this one, resting state is you can have this neutral line. Okay, isoelectric point. Fine. So no resting membrane potential is recorded. Okay, but when you apply threshold stimulus, you can see here this threshold stimulus will generate action potential. Okay, impulse is conducted and we can record the potential in two phases. How, that we will discuss. Fine. So first, why these two phases are there? Just a minute. This is your biphasic action potential. This kind of just let me erase all. So this kind of two phases, upward and downward deflection, they are found. Now, how these two phases are recorded, you can see here. Suppose initially there is isoelectric, or you can say when there is resting state, what happens, inside is negative, outside is positive. So this is resting state. Fine. Now after that, here this part is stimulated. Okay, when this part is stimulated, you can see here what happens here. This one, inside positive, outside negative, because of entry of sodium ions. Okay, so here what happens, that in recording, first when wave of depolarization reaches to a point A here. Fine. At this first recording electrode, what happens, because both the electrodes are placed extracellularly, you can see here negativity initially inside, now positivity is, you can see here, positivity is inside and negativity is outside. This is resting state and this is depolarization. Okay, so this one, this depolarization when reaches to point A, okay, this becomes negative. This is negative as compared to this other one. Okay, this A point is negative as compared to B point. Fine. Hmm? And therefore potential difference between these two, that is positive, so you will get this kind of upstroke. Fine. Then when wave of depolarization reaches between these two, again you can see both of them, they are equal. Okay, both the side, there is, you can see here, there is negativity inside, positivity outside. So now there is no difference in potential. Again you can see you will be having isoelectric line here. Fine. Then when impulse reaches to point B here, again there is depolarization. What happens when there is depolarization? There is positivity inside, negativity outside, because of depolarization is here. So what happens? This is negative as compared to the positive, and the difference between these two is, you can see, downward deflection. Okay, that is recorded. And again when this potential reaches beyond B, again you will find this isoelectric line. Okay, so this way two phases are recorded. Okay, now another important thing here is duration of isoelectric interval. This interval isoelectric, that depends on this duration of isoelectric interval. It is proportionate to two things. Number one is speed of conduction of tissue. When speed is fast, this duration is less. Okay, and also it depends on the distance between two electrodes. Okay, distance between two electrodes. When distance is less, this duration is also less. So this is inverse, this duration is inversely proportionate to speed. Speed more, duration less. And duration is directly proportional to distance. Distance less, duration less. Fine. So this is the thing which you have to remember. Another is biphasic action potential. It can be recorded change in the membrane potential. Okay, what is the only drawback here? We cannot record resting membrane potential. You can see here in resting state there is isoelectric line is found. You will not found any change in the membrane potential because both the electrodes are outside the cell membrane. Okay, now we come to monophasic action potential. Okay, now what happens? Monophasic, we all know how to record. One electrode is inside the cell and other electrode is outside the cell. Fine. And the difference in the electrical potential field, that is recorded. Okay, another thing, another way to record monophasic action potential, that is you can record monophasic potential by placing both the electrodes outside, but one electrode is present on the normal tissue and other is electrode is placed on the crushed nerve or injured area. Fine. Why why we will get this monophasic action potential here? Because when we have placed the electrode on the crushed part or cut part of the nerve and other on the intact nerve or intact part of the tissue, what happens? This crushed or cut part, that is always negative. So here that is always negativity, and here the potential changes. Fine. So we can get the difference in the potential and that can be recorded. Therefore, under resting condition, this difference in the potential is recorded. So we can record resting membrane potential as negative as compared to the positive one. Okay, so resting membrane potential is negative. Then we can record the change in the membrane potential in the form of depolarization and repolarization. Okay, fine. Now, so how this phases we can record? I think all of you are knowing normal monophasic action potential we have discussed. Suppose here this is your resting state. Okay, resting state, negativity inside, positivity outside. Fine. Now when stimulus is applied, you can see here, suppose the stimulus is applied here. So what happens? This inside becomes positive because of opening of sodium channel. So when inside becomes positive, your membrane potential instead of minus 70, now it rises, and during this depolarization phase it rises reaches to plus 35 millivolt. Fine. Okay, and as the depolarization is over, when sodium influx stops, there is exit of potassium ions because potassium channels open and potassium is intracellular cation. So when potassium comes out, what happens? This area now is getting repolarized. Means now what happens here? There is again negativity inside, positivity outside. So again this membrane potential comes back to normal. Fine. So this way we can record the this action potential in normal nerve. Now, what happens when we are recording between injured nerve and the normal nerve? Okay, when you can see here, this one, as we have discussed, one electrode is placed on the normal tissue and other electrode is placed on the injured nerve. Now, how will we get this kind of monophasic electric potential? Okay, so here you can see when impulse passes to the portion of the, or you can say when threshold stimulus is applied, okay, and when it reaches here, okay, this one, okay, portion of the nerve which is healthy, okay, here. So what happens? This is always negative, and this becomes negative outside, positive inside. Okay, so here the potential difference is there, that is recorded. Then when it reaches here, between this normal healthy part and the crushed part here, okay, between two electrodes, so the potential comes back to the original negative position because both are negative. Okay, so this is injury potential which is recorded. And when impulse reaches the electrode overlying the damaged area, as I told you, damaged area remains negative always. Okay, on stimulation of, on stimulation we will not get, we will get only this phase, okay, not this one of biphasic. Okay, in spite of we have placed two electrodes outside the cell. Okay, if we have placed two electrodes outside the cell, we should get this kind of curve, but we will not get, we will get only this curve. This is monophasic action potential which is recorded when one electrode is placed on the normal and other is placed on the your injured now. Okay, now next is what is the application, clinical use. As I told you, clinical is important. Clinical use of the your action potential. Okay, extracellular recording, that is helpful to judge the electrical activity of the excitable tissue, that is used for the EEG, electroencephalogram. Here you can see these electrodes are placed on the scalp and recording is made. Okay, second is ECG, electrocardiogram. Here you can see electrodes are placed on the heart and recording is made. Third is EMG, electromyogram. Here electrodes are placed on the muscle and the recording is made. Fine. Next is compound action potential. So what is compound action potential? Here you can see this is monophasic recording always. Here you can see only one deflection, upper deflection is there. So this is monophasic recording of, monophasic recording of action potential. Fine. And this is recorded from mixed nerve. Mixed nerve has different nerve fibers, okay, with different diameter. Suppose some are large, some are small diameter. So when we are recording the action potential from mixed nerve, we will get this kind of compound action potential, and that is because of summation of action potential of all these nerves, large one, small one, and all. So that is your compound action potential. When we are giving, we are stimulating a nerve which is having multiple nerve fibers, their all summation addition is made, and we will get this kind of action potential. You can see here big curve, this is small, this is of different height. Fine. Now, as we have discussed, different stimuli are there for action potential. This is the same thing. Subthreshold stimulus will not produce action potential. You can see here when it is less than minimum, no action potential is produced. Okay, when the stimulus is threshold, you will get action potential. But when it is supra threshold or submaximal and maximal, there is no increase in the strength of the action potential. Okay, so action potential once produced, that will not be increased with increase in the strength of stimulus. Fine. This follows all or none law we have discussed. Okay, now, so this is again, you can see we have discussed compound action potential, that is recorded by placing electrodes on the mixed nerve. Okay. Another thing, here when we are placing electrode on the compound, on the mixed nerve to record compound action potential, what happens? With increase in the strength of stimulus, you will get different responses. Why? Because different nerves or different nerve fibers are stimulated. Okay, so when stimulus applied is higher than maximum, okay, no further increase in the response found. But if the stimulus is less than maximal, sub-maximal, then you get different responses. Okay, so in mixed now compound action potential, it shows multiple spikes. Why multiple spikes? Because different fibers of different diameter are present. Fine. Now, which are the factors they affect compound action potential? One, that is type of fiber. You can see here number of fibers and size of spike. They are different depending on the type of fiber. If the fiber is thick one, then you can say that you will be having fast conduction. Okay, thick fibers, you can see number of fiber and size of spike vary with the type of fiber. Okay, another thing is strength of stimulus. The shape of compound action potential, that depends on number and type of fiber, but they are stimulated by strength. If the strength is, as we have discussed, subthreshold, it will not be going to stimulate the, it will not be going to produce action potential. Fine. Now, very important thing is coming now, that is what is the difference between graded potentials and action potential. Okay, what is this graded potential and what is action potential? Graded potential means, suppose if we have given subthreshold stimulus, you can see subthreshold stimulus is given, you can see here. So slight change in the membrane potential, it has not reached to the threshold. Slightly depolarization or hyperpolarization sometimes if the stimulus is inhibiting. Okay, so you can see electronic or graded potentials, they are developed when subthreshold stimulus is given. Here subthreshold stimulus cannot stimulate the tissue. Okay, but it will produce local, very important thing, non-propagated. Non-propagated means it will not pass like action potential. Okay, like action potential passes here on the membrane, but this will not pass. Okay, so graded potential, important characteristic, they are local, non-propagated. Third thing, they are summated. Summation takes place, that will not be there in the action potential. Okay, local, non-propagated, summated potentials. Okay, these are also known as graded potential, and they will not follow all or none law. Okay, not be followed by graded potential. Okay, but here you can see when we have applied subthreshold stimulus, but if suppose we have applied threshold stimulus, so what happens? Then there is propagated action potential is generated. Fine. So this is the difference between electronic, electrotonic or graded potential and your threshold potential or action potential. Fine. Now, this graded potential, or you can say local potentials or electrotonic potential, they are again of two types. Number one is cat electrotonic potential and other is electrotonic. You can see here, this is cat electrotonic. What is cat electrotonic potential? When we have applied cathode subthreshold stimulus. Cathode stimuli, they are depolarizing. Okay, so this, when cathodal subthreshold current is applied, that produces local depolarizing potential changes. Okay, this local depolarization of the membrane occurs, you can see here this. Okay, and current flows outward. So when current flows outward, inside is depolarized, and therefore it is known as cat electrotonic potential, positive deflection. Fine. Opposite is also true. When we have applied anodal subthreshold stimulus, you can see here this kind of hyperpolarizing responses are there. Okay, these are localized, same thing, localized hyperpolarizing, not depolarizing, sorry, these are hyperpolarizing changes. And here current flows inward, so inside the membrane is hyperpolarized, and this is known as an electrotonic potential. Okay, this cat electrotonic and an electrotonic both are known as electrotonic potentials. Fine. Potentials. Okay, fine. Now, so you can see graded potential. Graded potential, as we already discussed, when subthreshold stimulus is given, suppose only it increases the potential 7 millivolts. So what happens? You can see either depolarization or hyperpolarization of the membrane. Okay. Now the graded potential size is proportionate to the magnitude of stimulation. Okay, magnitude of stimulation means if we are stimulating more, more will be the graded potential. If we are stimulating less, less will be the graded potential. And some of the examples of graded potential, they are receptor potential at the site of receptors. at the synapse, postsynaptic potential, at the end plate potential, and pacemaker potentials in the pacemaker tissue, they are all graded potential. Okay, and we have discussed properties of graded potential, so we will discuss difference between graded potential and action potential. You can see here, first is localized. They will not propagate like action potential, they remain at the particular part only. Second thing, they are initiated either spontaneously or by neurotransmitter or by environmental stimuli. Any of the stimulus that will produce action potential, that may also produce electrotonic or graded potential if the stimulus is less than threshold. Fine. This is graded response. Okay. Means summation is possible. You can see here 1 plus 2, 1 plus 2 plus 3. This is possible here, summation. They are either depolarizing or hyperpolarizing, upward or downward. It has no threshold and it has no refractory period, and it will not follow all or none law. Okay. Other is action potential. Now, what is action potential? All the properties are opposite. This is propagated, initiated by, again same, depolarization of the membrane by the stimuli. Summation is not possible in case of action potential. They're always depolarizing. You can see here in this reduction only. Okay, they require threshold stimulus. Okay, and refractory period is present, and it also follows all or none law. So these are the differences between graded potential and action potential. I repeat, graded potentials are non-propagated or local. These are propagated. Summation possible, depolarizing or hyperpolarizing, no threshold, no refractory period, no all or none law, and all are present here in the action potential. Okay, fine. Now we'll discuss about question answers. Today's topic was short, so let me finish and start with the question answer session. So if you are watching me live, you can give answer in the chat box, and if you are watching the recorded video, then also you can write down your answers if you can. Okay, starting with the first one. Which of the following is not associated with nerve transmission? Sodium ions, magnesium ions, chloride ions, and potassium ions. As we all know, sodium, chloride, and potassium ions are concerned in the nerve transmission. So the ion which is not associated, that is our magnesium ion. Fine. Then the charges are due to flow of electron, proton, neutron, proton, and neutron. And that is the answer, as we have discussed. They are like electrons, they are moving, negativity and positivity. So the charges are due to flow of electrons. Fine. For subthreshold stimuli, all are correct except do not produce action potential, do not have effect on the membrane potential, do have effect, sorry. They are weak current that fail to stimulate the tissue no matter how long duration of the current flow, and are used to analyze resting membrane potential. What is the correct answer? Which is not for subthreshold stimulus. Hmm? Subthreshold stimuli, they are used to analyze resting membrane potential is not. Thank you, Dr. Sheetal. This is not the correct answer. Okay, fine. Next is the point at which spike potential or action potential is generated. Okay, we have discussed initially the membrane potential is minus 70. Fine. Okay, then once it reaches to minus 55, then there is fast opening of sodium channels. So this is the point at which spike potential or action potential is generated, and that is firing level. So this we have discussed, this is firing level. Fine. Next is stimulation normally occurs at cathode because cathode stimuli are hyperpolarizing, cathode stimuli are depolarizing, anode current inhibit impulse formation, and all of the above. So as we know, cathode stimuli are depolarizing. They cause like this membrane depolarization this way. So Once it reaches to threshold, that will generate action potential. Fine. Next, all statements are true for graded potential except one, they are confined to a relatively small region of membrane. Second, their magnitude is variable. Third, they are given various names like end plate potential, pacemaker potential, etc. And they obey all or none law. We have discussed action potential obeys all or none law. Graded potential will not obey all or none law. Fine. Next. Graded potential differs from action potential in all of the following except graded potential. So characteristic of graded potential, it has no threshold, that is one, yes. It has no refractory period, it does not obey all or none law, and it is important in signaling over long distance. This graded potential will not allow the impulse to pass over the long distance. This is for short distance. Okay, fine. Next, which is true regarding now conduction, that is all or none phenomena. Conduction is independent of amplitude. Propagated action potential is greater in dendrites and subthreshold stimulus is required. As we have discussed, conduction, that is action potential which is conducted, and action potential follows all or none phenomena. So this is correct option. Fine. True about extracellular recording of action potential. Extracellular. One electrode is placed on the surface and other is inserted into the cell. This is not correct. As we have discussed, extracellular means both the electrodes are outside. It cannot record changes in the membrane potential. This is also not correct. Okay? It can record change in the membrane potential. Biphasic action potential is recorded. It cannot record resting membrane potential. This is the answer, because as we have discussed, when both the electrodes are outside, we will not record action resting membrane potential, and it can provide record for accurate analysis of action potential. This is also correct option. Next, monophasic action potential. It has single upward deflection. It is the intracellular recording. Monophasic, not intracellular, as we have discussed. Monophasic, one extracellular, one intracellular. Provide accurate record of action potential. No, this will not provide. Biphasic provides accurate record. And record shows upward deflection followed by downward. No, in monophasic we have only one deflection. So correct option for monophasic action potential, that is this one. It has only single upward deflection. Okay. So this is all about today's topic. We are completing action potential here. Thank you all. Thanks for watching me. Another announcement, as I told in the beginning of my class, that all my topics that are available in all my topics are available in soft copy as well as hard copy. If you wish to get soft copy, you can download the app Baselius and subscribe it. And for hard copy physiology notes book, that is also available. You can order from Flipkart as well as Amazon. Okay. As well as our practical app is also available, that is Practicable. Okay. So you can also download the same. Links for all are given in the description box of the video, so you can go to description box, get the link, and you can download as well as subscribe. Thank you all. Thank you so much. If you like my video, you can like it, you can share with all your friends, you can subscribe my channel Dr. Deepti Thakkar Karya, and you can hit the bell icon, so you will get all the notifications. Fine. Thank you so much.